Okay, guys, hey, here we go. 2.4 population dynamics. Take a minute and set up your notes. Whoops, like this. Pause here. Here we go. All right, so first question is why is global population increasing? Well, lots of stuff. So we're going to look at the components of population growth, and the three main features are what happens with our crude birth rate, crude death rate, and then the difference of those is basically called natural increase rate. So simply put, crude birth rate is the number of live births per 1,000 people in a society per year. The death rate, same number of deaths per 1,000 people. And then you basically take the difference, you subtract the CDR from the CBR after they get converted into a percentage. And then what you're left with is called the rate of natural increase. 21st century, worldwide, we had a 1.2% natural increase. 1963, that actually was at 2.2%, which is pretty much significant. And up until that point, all the way through most of history, we actually were at almost a zero. So again, this has just changed over time. And these demographic factors are impacted by economics, they're impacted by social, political, and natural processes, ESPN. Keep in mind, natural increase rate does not include migration. This is simply just what is happening naturally. Okay, whoops. So here we are. Let me move myself around again. Moving person. So this is a crude birth rate, and this is a lovely choropleth of shaded colors. So basically, your dark purple, there is a crude birth rate of 40 and above. And then you get all the way down to like the very light colors, which has like a below 10. Now, what you guys need to understand is just because there is a lot of babies being born in these parts, especially sub-Saharan Africa, unfortunately, there is also a correlation between the crude birth rate and then the infant mortality rate. Unfortunately, more often than not, these babies do not survive long enough to become reproducers of their own. All right, and then what we got here is the natural increase rate in the world. So again, this is that difference of the crude death rate and the crude birth rate, and then convert that into a percentage. Currently, Niger has the highest rate of natural increase, growing at 3.78%. I mean, so this is phenomenal population growth. Bulgaria is in Eastern Europe, and they are currently losing their population at a rate of negative 2.79%. Ours right now is actually negative 0.65. Now, think about this for a minute. Our population in the United States is still increasing, but how is that possible with a negative 0.65% rate of natural increase? Migration, which again, not calculated in these numbers. We are a country people want to come live in. So even though we are not naturally making all these new babies, our population numbers still grow because of people wanting to come and live here. We have way more immigrants than emigrants, people leaving, okay? All right. So components of population growth, and these are going to be those factors. So again, in your notes, we're on the factors page. I'm trying to find myself. Okay, Maury, recent study suggests 3 out of 4 people make up 75% of the population. Ha ha, that's a good one, Maury. Okay, so when we're looking at natural increase rate, definitely have to take into account what we would consider the doubling time. That's basically the number of years needed to double the population if that natural increase rate remains constant. In 1963, at the rate that natural rate was, we were going to double our population in 35 years. However, natural increase rate dropped, so therefore we did not actually double, which is good. I'm not sure we could have probably dealt with that, okay? What are the trends that we're seeing right now? So most natural increase still is happening in developing countries. Sub-Saharan Africa as a whole has a higher than 2 natural increase rate. Europe actually is shrinking. So again, without immigration, their natural births are shrinking. And most of the world's additional people live in countries that are the least able to provide, unfortunately. So again, we have this is a problematic correlation between places that are growing and are having more kids, but that country's ability to provide for those kids is inverted. It doesn't match. All right. When we look at population growth, we have what we would consider an exponential growth, or we call it J curve, that happened in the late 20th century. So if you guys think back to 2.3 notes, we talked about the factors that influence like the shape of a population pyramid. So again, this directly correlates with like, was there enough men around? You have to have a, biologic male, biologic female. So if there was a bunch of men gone for war, or if there was a natural disaster that wiped out a good chunk of the reproducing age people, those people obviously cannot any longer reproduce. And then you have the societal choices as well. There is a direct correlation between women's access to education and jobs that has put women in positions to say they're not having all these children anymore because they want to, take advantage of education. They might choose to say we're only going to have 2 to 3 kids instead of 7 to 8 kids to provide for. So what we start to see here, guys, you guys can see it's a J roughly, and it started pretty slow and steady. I mean, we're talking over a 200-year period, and then wham bam. I mean, you guys can see just what happens in developing regions. And so we just have this population explosion that is exponential. It just flies. Developed countries around the world, we obviously see this at a way smaller spike of number. All right, so again, what we have here from the difference between like a linear versus a J curve or exponential growth. So we see, a linear increase is like, okay, a nice steady, hey, we can plan and provide for that. But you obviously start to see what happens when you have this exponential J curve growth. This is hard to plan for, right? I mean, like you can't, like when you're chilling down here, you don't expect it to just whoop this much. So this is again where we start to see a big disconnect between a country's ability to provide. They might not have infrastructure in place. They might not have ready food or medical supplies. Keep doing that. All right, so let's talk about doubling time. The rule of 70 or 72, and again, it kind of varies on the sources you're looking at. Simply put, doubling time is the time period required for a population to double. And so the way we look at this is that you take the number 70 or sometimes 72, again, your sources can vary on this, divide it by the natural rate of increase, and then what you get is a number, and that is going to be how many years at that current rate is the population going to double. Okay, so again, what we start to see here is this is kind of concerning data. If you are in sub-Saharan Africa, they are looking at roughly a 38-ish year doubling time for most of the countries in that region. That's not a lot of time to prepare for double the amount of people to provide for. On the flip, Europe, they've got some time. They've got some time to worry about what are they going to do when their population doubles, because it ain't going to happen for a while. Okay, North America, we're right kind of in this like kind of middle. At the rate we're at right now, about 100 years from now, we can expect roughly double our population. Okay, but again, this is also if you're if you're a politician, if you are in public service. These are the numbers you look at and you think, okay, are we ready for this? Are we able to know that we're going to need, that we have this many schools available? Do we have this many correctional facilities or prisons available to support this growth and statistically who we can expect to be part of those institutions? All right, so then another thing we talk about is the demographic balancing equation. I'm like literally bouncing all over the place. And this is kind of like, what do you need to have to maintain status quo, right? Like keep things as is. The way we look at this is you have your births, you minus your deaths, that gives us our rate of natural increase. And then when you add in net migration, so migration itself is just simply people moving from one place to another. The net migration is immigrants, people who've come in, and then the difference of emigrants with an E, the people who have pieced out and left. And so once you get that net number, so basically people who've stayed after they've either came or went, plus the natural rate of increase, that is what gives us the demographic balancing equation, which gives us a more like actual accurate number of after and people come in or take off, what we can expect to be left with. All right. So demographic factors that determine a growth or decline: fertility, mortality, and then migration. So again, that's why we look at migration as part of this unit. Oh, look at those Baileys. Oh, this is one of my favorite movies. Bonus points if you know what movie this is. Or maybe your parents know what movie this is. Ask them and then message me for the answer. It's a great movie. All right, population growth and decline. So again, we're looking first at fertility. So fertility is basically how fertile or able are the able to result in babies. The thing you guys need to be really concerned with here is the crude birth rate, which is again the amount of babies born out of 1,000, and then total fertility rate, the number of children a woman can be expected to have during her childbearing years. Childbearing years vary depending on where in the world you are, but it is kind of typically accepted as childbearing years are roughly between the ages of like 15-ish all the way up through about 60-ish. And again, socially, that number is different depending on where you are. But as far as like your body's ability to be fertile and reproduce, for young women or for girls, like women, females, 14, 15-ish to about 60-ish, okay? Worldwide average, 2.5. No, you're not having the half kid. It is just a statistical average. Breaking it down, sub-Saharan Africa, 5. It is assumed, and it is the trend, that childbearing women will have 5 children in their lifetime. You come to Europe or most other countries in the world, you actually are at 2 or less, okay? So again, this is a really, really interesting thing. So that total fertility rate is a huge impact on future population behavior. That is the stuff that really affects the shape of a population pyramid. Whoops. All right, so this is a map of the total fertility rate in the world. Again, a nice little choropleth here. So dark orange countries, they have on average 4 or more children during a childbearing years, all the way down to like below 2, and then the no data countries, okay? So again, you can see the United States, Canada, much of Europe, China, what is that from? One child policy. Brazil have less children, and then you can see the flip. And this pattern, I'm hoping you guys are starting to see, you've seen a lot of world map choropleths, and there's so much correlation between economic level, development level, agriculture. I mean, all these factors, population demographics, you can see it reflected in the same regional patterns throughout the world. All right, so mortality. Perfect for spooky season. If you're a Game of Thrones fan, you'll appreciate our GIF. Death, death, death. Okay, mortality. This is basically what is the expected death rate and in this area. And what they have to figure in is, are people more or less likely to die before or after they may have had children? So this is hugely important in what we talk about in the demographic transition model. So DTM in your notes, make sure you just write demographic transition model. There is way more to come. That is probably one of the most important lessons we'll do all year, and we're going to do that back in person, okay? What you need to understand about CDR is that unlike crude birth rate or total fertility rate, there isn't as huge of a difference in countries' CDR around the world. Might surprise you. Denmark actually has a higher crude death rate than Cape Verde, which is a developing country. The United States has a higher crude death rate than Mexico and most other countries in Latin America. But what impacts that number is also factors that come with when you have a older population, then when they start to die, it happens, that group dies out pretty quickly. But you have to be a pretty developed country to get to a place where you have a lot of old people. But there's also there's a natural limit, right, to how old a human can live, no matter how developed of a country they're in. So Denmark and the United States, very, very developed countries, we can have a lot more old people because we have the medical, technology and access to medical care to keep old people alive longer. But then all of a sudden, when they die and that whole age group dies out, that makes our crude death rate go up higher. All right, so here's again map of crude death rates around the world. And so what we're looking at here is the correlation between, out of every 1,000 people, how many are expected to die within that crude death rate, excuse me. And again, you guys can see this same pattern going on throughout the world. All right, so population growth and decline, how do we, after we look at all these numbers, what does this actually even mean? So we have arithmetic growth, which is simply basic, that's the amount of new people that are living in that area. And then we have exponential or geometric, or that J-curve growth. And again, remember, that's that rule of 70 or 72, which estimates the doubling time it's going to take for that population to go from whatever to the J slope. Okay? My girl, Leslie Knope. All right, so again, arithmetic is an increase in a constant number. Addition of 1 each year would be 1, 2, 3, 4. Pretty straightforward. Exponential, this is when we start to double. We go from 1 to 2 to 4 to 8 to 16. You keep going infinitely, okay? Exponential growth since the early 1800s, again, using that rule of 70 or 72 to estimate the doubling time, we've started to see this same pattern. So for example, on the Ivory Coast, or in the Ivory Coast, which is in West Africa, basically they are expected to double their population right now in 35 years versus, get out of my way, stupid, this thing is in my way. There we go. Versus the United States, that we have a US growth rate right now, or a doubling rate of about 90 years. So pending we stay on the same track we're in, we have about 90 years until we can expect a double population. All right, most of these factors are related to ESPN, which are going to be economic, social, political, and natural consequences. All of these things, there's actually a really interesting subset of data called the Human Development Index. And they basically just kind of look at many factors that go into how good of a life do you have somewhere, based on education access, healthcare access, decent standard of living. Do you have money to provide your basic needs and have a little fun? And they can aggregate all that data and they come up with this HDI. Basically, the higher up on the HDI, the better off humans are, which obviously is going to impact migration. Places with high HDI are desirable, so people will go move there. People don't typically tend to leave places with high HDI. On the flip, if it's a low HDI, those are places that, consequently have lack of access to healthcare. So you might have a very high crude death rate, or you might have, high fertility among women, because they might have 5 kids over their lifetime, but only 2 of them actually live past the age of 3. So again, correlation there. Looking at this choropleth, the dark green are high HDI indexes. Again, same pattern we start seeing over and over. North America, Europe, Australia, Japan, South Korea, very developed, happy, good, people are taken care of, places to live. And then you start to see the other end of this, which is the lower end of the development index. If I was to layer this map with the crude birth rate, the crude death rate, any of those other subsets of data we've looked at, you guys are going to see direct correlation in the patterns. Okay. Economic development.